Hi, and today we're going to look at collecting like terms doing single variable addition. So, easiest, it's a little bit of worded, but I'm going to go through this because it needs some context a bit, right? Once we start rolling, you won't really need this at the beginning, but our variable, okay, in the equations below, I chose this as x. It can be anything though, okay, as it's just an unknown quantity. So give the example boxes of pens, boxes of rulers, stuff like that. Our unknown is how many are in that box. We know that it's a box of rulers. We know that they're rulers, but we want to know how many. So this is why we indicate them with unknowns, which are variables, x, y, z. So I'll use the word unknowns, variables, interchangeably. Sometimes letters, but really not, because it's not very mathematical. But collecting like terms just means we want to simplify our expression. So if we look at x plus x, well, is there any way we can write that so we don't have that operator maybe? Well, I can write that as 2x, right? If I have 1x and I add another x, I have 2x. It's like if I have an apple and someone gives me another apple, I have 2 apples. So I could say I have 2a, a for apples, right? Because we don't know what kind of apples or maybe the size of apples. Maybe that's what's important. Anyways, so we can collect only with similar variables. And that through addition, we just end up getting a number out front, which is our coefficient of our x. Okay? So the number outside of a variable is called our coefficient. As long as the variables match, we can perform the 4 main operators as if there was no variable or letter. So notice if I have 1x plus 1x, like I did up top, but I just put 1s, I can write that as 2 x's. Okay. Notice what's different between here and here, or here, is that I included the 1x on the right, but I didn't really need to, because if I have just x, that means I just have one of them. So let's actually do these examples. So one thing I try and tell people, and we'll do it from the start, is when you see your terms, if there's, say, x's, underline everything that has an x and the operator to the left-hand side. So this is all together. Right, because that's saying we have positive 3x's. So if we have positive 2x's and positive 3x's, well, we know that 2 plus, we'll just drop the x's and go 2 plus 3. Well, that's 5. And then we can just put this x on at the end. Okay. Here, well, if it makes it easy, put the 1 to begin with, but just make sure that we don't actually write them ever. So we have 1 plus 1, so this is 2 together. Then if we add on this, then we have plus 3x, which is 5x. And then we're going to add on this 2x. So we're going to have 7x. Or you can think of it as 1 plus 1 is 2, plus 3 is 5, plus 2 is 7, and then put the x on at the end. Lastly, we want to simplify x plus 2 plus 3x. So here, I see a plus x. Here I see a plus 3x, but this is a plus 2. So we can't actually combine that. So I'm just going to circle that in green so I don't mess it up. And what you notice is I can move them. This is a nice property of maths. I can move my terms around when they're addition and subtraction as long as I don't change this sign outside of this 3. That's why I said keep the sign to the left-hand side and we can move them around. We're going to do this a lot. So here, I'm going to rewrite this over here as x plus 3x plus 2. Now you can see that we have this x and 3x, which it will just be 4x, and then we just have this plus 2 on the end. So we can't actually combine those because it's like saying we're trying to combine two floor tiles with 2 apples, right? We're not going to be able to do that. But our 2 is just a number. We don't care. It's just the number 2, and we're saying, hey, 2, do you want to go fit inside this pie or something? It just doesn't make sense. The examples don't make sense because it doesn't make sense adding a letter and a number together like that. So